Okay, so today we're going to start chapter 1. We're going to break lesson 1 into 2 lessons. The first day is 1-1A. We're going to be solving linear equations. So our first linear equation is right here, and what we need to do is solve for x. So what we're going to do first is we're going to distribute. Now, I'm going to distribute the 2 on the left side, or sorry, the 3 on the left side. So I would get 6x minus 12. Now be careful right here because I need to distribute the subtraction sign, or you could also think of this as got like a -1 here that you're distributing. Either way, but I'm going to distribute it. So I get 7 minus x minus 5. Now I'm going to combine my like terms over there on that red side. So I would get 6x, I'm just rewriting the problem, equals, and I'm going to combine the 7 minus 5, and I get 2 minus x. Now I'm going to move my variables together, and again, it doesn't matter which way you move them. So I'll move the x over here, and I get 7x minus 12 equals 2. Then I'm going to add the 12. 7x equals 14. Divide by 7. And x equals 2. Now remember, whenever you solve for a variable, you can always check your answer by plugging it back in. So I'm just going to do it on the first one to just show you how you could check. So I would take the original problem, the 3, 2x minus 4 equals 7 minus x plus 5. Take out x, put in 2. In every place that you see x. So over here, I'll do the innermost parentheses and get 4 minus 4. Over here, 7 minus 7. So then 3 times 0 is 0, and 7 minus 7 is also 0. So when you plugged it in and you got a true statement here, both sides equaling the same number, then you know that this answer of x equals 2 is the correct answer. Pretty good? Let's try another one. Now this next one has fractions in it. Now you could work with the fractions. You could subtract the 1/4 over to the 1/2 and work with it this way. But I find it a lot easier if you clear the fractions before you begin. So what I'm going to do is I'm going to look for the common denominator between 3, 2, 4, and then I've already said the 3. So my common denominator between those 3 numbers is 12. So I'm going to multiply each piece of my equation by the common denominator of 12. So if it's easier for you to see like a little 12 in front of each one, because really what you're doing here is simplifying that denominator. So if I put a little 12 next to each of these, so then I would simplify. 3 goes into 12 4 times. So that's what you're going to multiply that numerator by. Then the next one, 12 divided by 2 is 6. So then this becomes 6x. Then on the other side of the equal sign, again you can do 12 divided by 4, and this becomes 3x. And then here, 3 divided by 12, or 12 divided by 3 is 4, and then you multiply that to the 7 that's there. And I can just show it like that. So now I'm going to distribute. Yes?
Wait, what do you multiply it by?
So now let's distribute. So we would get 8x plus 16, drop down the 6x, 3x, and then I would multiply 4 times 7. I'm going to combine these like terms on the left side, and I get 14x plus 16 equals 3x minus 28. I'm now going to move my like terms together, or move my variables together. So I'm going to subtract the 3. And then subtract the 16. 11x equals negative 44. And then divide by 11. And x equals negative 4. You could also plug it in and do the check, but it is correct. Let's try the next one. Next one. No fractions here, we're just going to distribute. So the 4 to the -2, -8, 4 to the 1, drop down the 6, distribute the negative sign, and now combine like terms. So this becomes 10 minus 2x. I'm going to drop down the other side here. And now I can begin to use my properties of equality. So I could move the 8 to the right, but I'm going to move my letters left. -6x plus 4 equals 10. Move the 4. -6x equals 6. Divide by -6, and x equals -1. Pretty good? This one's got brackets and a parentheses. So again, I'm going to work from the inside the bracket, that innermost parenthesis first. So I'm going to distribute the negative sign. So I'm going to put the 4 in the bracket, the 2x, distribute that negative sign, rewrite everything. Now I'm going to combine like terms within the bracket. So 2x plus 1x, and then I'll do -3 plus 5. So in my bracket now I have 4, bracket, 3x plus 2. Next I'm going to distribute the 4. 12x plus 8, -7x minus 2. I'm going to now move my variables together. So I'm going to add 7x to both sides. 19x plus 8 equals -2. Subtract the 8. 19x equals -10. Divide by 19. And x equals -10 over 19. And you can leave it a fraction. You don't need to divide it and make it a decimal. Again, so we're going to go ahead and clear the fraction. So my common denominator here between 5 and 3 is going to be 15. So I'm going to multiply the whole thing by 15. Or again, what are you going to multiply 5 by to make it 15? And that's what you would multiply the top by. Now, when we do this, I'm not going to do it to what's in the parentheses. So if I have something that's with a number outside the parentheses, the only thing I'm going to multiply the 15 to is what's outside the parenthesis. And then this one to 15. So this one is going to simplify to a 3. This one will simplify to a 5. So 3 parentheses 2x plus 5 equals 5 parentheses x plus 2. Now I don't have any fractions, so now I can distribute. So 3 times 2x is 6x. 3 times 5 is 15. Distribute the 5 to the x and the 5 to the 2. Now I can begin getting my variables together. So I'll subtract 5x. And then I'll get my constants together. Subtract the 15. And x equals -5. Yes?
How did you get rid of the denominators?
Okay, so maybe if I show it, let's see. Let's do 1/5, 2x plus 5 equals x plus 2 over 3. So I'm going to find the common denominator between 5 and 3, and it's going to be 15. So what I'm trying to do is make this denominator of 15, and basically what you're doing is you're finding the common denominator, and then you're going to multiply everything by it. So if I put a 15 over 1 times this, and a 15 over 1 times this, then this simplifies and it becomes a 3. So then I now have 3 over 1 times 1 over 1, which is just 3. So now I'm distributing a 3 to this. And then here, this 3 becomes a 1, this 15 becomes a 5. And then I distribute it to the top of the top of the fraction. Next one has decimals and fractions. Now, again, if you're comfortable with working with this as fractions and decimals, you can leave it. But what I'm going to do is I'm going to change the 2500s here into 1/4. Everybody realize that 0.25 is 1/4? Good on that? So I'm going to change this to 1/4 x. So now my problem is going to be 2/3 x plus 1/4 x equals x plus 2. Now, I could work with all these fractions, find a common denominator, add them, but what I'm going to do is I'm going to clear the denominator again. So again, my common denominator between 3 and 4 is 12. So I'm going to multiply everything by a 12. So this simplifies, and this becomes 4 times 2, and this is 8x. This simplifies, and it becomes a 3, and that's a 3x. Over here, nothing to simplify, so this becomes 12x plus 24, because I'm multiplying these things. Now I have a nice, easy problem with no fractions. I'm going to combine my like terms. So this becomes 11x, 12x plus 24, subtract the 12x, negative 1x equals 24, divide by negative 1, and x equals negative 24. Yes?
That's the same thing.
Everybody good? All right, I want to show you one before we move on to the screenshot that's there. Because this came up with the A period doing the homework. Let's say I have this question. 2x plus 1 equals 3x plus 1. When I go to solve this, and even if I move the 2x over here, I get 1 equals x plus 1, subtract the 1, 0 equals x. This is a valid solution. You can have an x equals 0. Everybody with me on this? So when the variables are different, but the constants are the same number, the constants are going to cancel and you're going to get x equals 0. X equals 0 is a valid answer. Okay? It's not going to be the special cases that I'm about to show you, where it's no solution and all real numbers. Let me also show you one where we have decimals in it and how we could clear a decimal point. So add a slide. So let's say we have 2/10 x plus 5 equals 4/10 x minus 4. It's probably going to be a bad situation here, but let's just do it. Now, if you don't want to, and it might get harder than this. This isn't that bad. But what you can do is multiply your entire equation by 10. Or essentially just know that I want to make this 2/10 x into a whole number. So I'm going to move my decimal point one time. I could put a decimal point here, move it one time, fill that basket with an egg, move this once, and move this once. So now my problem is just 2x plus 50 equals 4x minus 40. And then I don't have to deal with dividing by a decimal. So then now what I do is move the 4x, and I get negative 2x plus 50 equals negative 40. Then subtract 50. Negative 2x equals negative 90. Divide, and x equals 45. You don't have to move the decimal point back. As long as you've multiplied every term or moved the decimal point in every term, and even if it doesn't have a decimal point, still move it. Add a 0 to the number. Okay, this is a way to get rid of decimal points. But if you're comfortable working with decimals, you can leave it. All right, here's the special cases now, because you have one of these in the homework. So let me, now we've already talked about option 2 here. When we solve a linear equation for x and we get x equals some number, that's a single solution. Now, you're not going to have to identify something as an identity, conditional, contradiction. What I want you to do is either tell me x equals 5, x equals 10, whatever number it is, but in the 2 special cases that I'm going to show you now, if your variables cancel and you're left with either 0 equals 0 or the same side, both equations on either side of the equal sign are equal, both expressions, then it's all real numbers. If you're left with nonsense, like 2 equals 5, that's when it's no solution. So if you get something that doesn't make sense, then it's no solution. So when we're solving this homework, your answers are either going to be x equals a number, a single solution, or it's going to be all real numbers, or no solution. And I'm going to do the examples of the no solution and the all real numbers now. So again, the solving process is the same. We're going to distribute, we're going to combine like terms, combine our variables together, same thing we just did. So I'm going to distribute the negative 2x, combine my like terms, so I can add the negative 2x and the 3. I'm not moving it across, so I'm just doing negative 2 plus 3, which will be 1x. Now, if at this step you realize the expression on the left is exactly the same as the one on the right, you can stop here and say that your answer is all real numbers. Symbol for all real numbers, if you make a capital R and then you put another line down, that's the symbol for all real numbers. Later on, we're also going to see negative infinity to positive infinity. That'll be coming up when we start learning interval notation. But for now, you can just write out the words all real numbers. Now, let's say you didn't realize this and you wanted to keep going. So if I were to try to move my 8's together, now I'm left with x equals x. Still a true statement. If you try to move the x's together, that's where you get the 0 equals 0. But as soon as you realize that you have the same thing on the left that you do on the right, and it's perfectly identical, the answer is all real numbers. Let's try the next one. This will be the other situation. We're going to distribute the 3. And now I'm going to try to get my variables together. And notice now I'm left with negative 3 trying to equal a 7. That will never happen. So when this occurs, this is no solution. Now, when you go to write your answers, the answer isn't this. The answer is no solution. Same thing on the previous problem. The answer was all real numbers. You could have kept trying to go here and try to move something together, and then you would have gotten 0 equals 10. So this one is no solution. This will never happen. Negative 3 will never equal 7, so it's no solution. Let's try 2 more.
Leave it like that and then just say x equals 0, or do you have to still work it out from there?
Now, on this one with the fraction, use your good judgment. Like, if I look at this problem and I look at the 2 numbers that I'm trying to distribute the 1/2 to, they'll both go in evenly. So really, I don't need to multiply everything by a 2 to clear it. I'm going to actually just distribute the 1/2. So here, 1/2 of 6 is 3x. 1/2 of 14 is 7. I'm going to distribute the 2. And now I'm going to start looking to combine my like terms. So I can combine this 1x and 2x and get 3x. The 1 and the 6 and get 7. And as you can see, the left side equals the right side. So at this point, if you realize that, just write all real numbers. Either one of these you can put. If you didn't realize it and you kept going, let's keep going, get negative 3x equals 3x, and then if you try to move them together, you get 0 equals 0. Yes?
There was one that was like 2x plus 1 equals 3x plus 2.
So we ended up with what, 2x?
And then one of the previous questions.
Oh, the one where it was 0?
Can you just leave it as 2x plus 1?
This one?
Yeah, and then say x equals 0?
You could do that. Yep. Because you got to combine it and then you get x equals 0. Absolutely.
Thank you.
Uh-huh. All right. And the last one, we're going to distribute the negative 6. So it becomes negative 12x minus 6. Distribute the negative 3. Combine your like terms on this left side. Negative 12 and negative 3 give me negative 15. Negative 6 plus 12 is 6. Drop down the right side. And again, soon as you see that you're going to try to put your x's together, you're going to see that they're going to cancel. And again, you're left with nonsense. This will never happen, so no solution. So that is your first lesson of chapter 1. Now keep in mind, you need to go to the module and download chapter 1. So the PDF that you've been using for the review chapter, you now need to go back, remember, and get chapter 1 now. Because remember, I have those files broken into chapters. So that confused some people. So go to the module, go to that very first one where it says textbook and general class information, look for the chapter 1, and then get that file, and your homework is on pages 90 and 91, and it's numbers 9 through 35 odd. That's it.